Okay, so in this project we have a transformation from V to V, where V is the plane and R3 x1 plus x2 plus 3x3 equals 0. Okay, and we have, in respect to a particular basis, we are given this basis 1, 1, negative 1, and 5, negative 4, 1. Okay, so that basis spans the plane, and then we might notice that they are perpendicular. We can notice that by noticing that 1 times 5 plus 1 times negative 4 plus 1 times negative 1, 5 minus 4 minus 1 equals 0. So that means they're a perpendicular basis. And so that is always useful. And our particular transformation that we're supposed to do is an orthogonal projection onto the line spanned by the vector. So we want an orthogonal projection onto the line spanned by the vector (1, 1, negative 1). Now let's just recall what we mean by orthogonal projection. So we've got some plane, and we've got some line on the plane, or we've got a line on the plane. I didn't show the line as being spanned by a particular vector, so I'll do that now. Okay, so we've got this line on this plane, and we want to find the orthogonal projection of some other vector onto that line. So we've got some other vector, and we want to find its orthogonal projection. Well, this will be easier to do if we pretend that we're looking at the plane from directly above, and so it's just going to look like the xy plane. So let's just pretend that we've got that we're looking at our plane, so it looks like that. And let's also just say, let's just make this our line. So that's going to be our line that we want to project onto. So we've got some vector. We want to find the orthogonal projection of this vector onto that line, and so we just make the perpendicular right there, and the orthogonal projection onto the line is this part right here. Okay, so we notice in our particular projection, or our particular problem, that we are supposed to transform onto a line spanned by that vector. Now, also we might notice that the domain and the target space are both planes. So domain has dimension 2, and target space has dimension 2. So that means that when we make our transformation matrix, it's going to be a 2 by 2 matrix. So that's our transformation matrix will look like that. So what we've got here, we've got some nice vectors to deal with here, because we want the orthogonal projection onto this particular line. And so what we want to do when we find our transformation is we figure out what does our transformation do to each of our basis vectors. So that's what we want to figure out. And so we'll take our first basis vector, and we'll find the transformation of it. Well, that vector is exactly on the line that we're supposed to be projecting onto. And so we just get the entire thing, we get the whole part of it. And so the transformation is just going to be 1, 1, negative 1. So it just projects. That would be like in our example here, if we had this vector and we were saying to project it onto this line. Well, it's already on that line, so it'll just be the same thing. Now, if we look at our other basis vector, we already noticed before that it was orthogonal. And so if we take the transformation of 5, 4, negative 1, we're going to get the 0 vector. Now the reason for that is, again, if we just look at our plane from above, and here's our plane, and say this is the line we're projecting onto, if we have a perpendicular line, or a perpendicular vector, when we project onto that line, it's just 0, just the 0 vector. And so that makes our basis going to be particularly easy. So our transformation matrix B is going to be the transformation of the first basis vector in our new basis, and the transformation of our second basis vector in our new basis. And so what this is going to look like is this vector in the basis of this and this is 1 times this basis vector and 0 times this basis vector. So we get 1, 0. And this 0 vector is 0 times the first basis vector plus 0 times the second basis vector. So 0, 0. So that's our transformation matrix. So notice in this last step, I kind of went through it a little quickly. Let me just explain again if I have them all on the screen. So I don't have them all on the screen. Okay, so now our basis that we were given was 1, 1, negative 1, comma, 5, 4, negative 1. And we wanted to find out what each of our transformations was in terms of those vectors. So our first transformation got this. And so in terms of our basis vectors, 1, 1, negative 1, that was what we got from the transformation. That equals 1 times our first basis vector plus 0 times our second basis vector. And what we got from our second, so for the transformation of the second basis vector, that's what we got. And so what that is, so 0, 0, 0, what that is 0 times our first basis vector plus 0 times our second basis vector. So when we write our transformation matrix, we've got our 1 plus 0, so 1, 0, and our 0 plus 0, so our 0, 0. So that's that. Okay, bye.